Hi friends, welcome back. Today we are going to solve another very recent and quite popular string related medium complexity coding interview question on Leetcode 2645 minimum additions to make valid string. As you can see here from like dislike ratio, this is another quite likable string related coding interview problem. This is quite recent problem on the Leetcode. So we are going to go through this problem today. We are going to understand this problem today with some examples, and we are also going to implement our Java solution code to solve this coding problem. If you are new to this channel, please subscribe to this channel now. Also click on the bell notification icon button right away so you won't miss any important postings from this channel. Here we create videos to help others in their interview preparation and learning different computer science concepts along with data structures, algorithms, problem solving, logic building, programming and coding. So let's start. Given a string word to which you can insert letters A, B or C anywhere and any number of times, return the minimum number of letters that must be inserted so that the word becomes valid. A string is called valid if it can be formed by concatenating the string ABC several times. Right? So this is what the problem says. Constraint says that the word dot length is between 1 to 50 inclusive. Word consists of letters A, B and C only. So let's take a look at some examples. So this is first example, right? So if you have a word B, then how can you make it a word ABC? So you definitely have to insert A in the beginning and B, after B you have to insert C, right? So you have to make two insertions here so that this string becomes ABC. Minimum number of insertions so that the string is a valid string. A string is valid if it can be formed by concatenating a string ABC several times, correct? So this is the case where you have to insert two characters A and C. In this case AAA, right? So let's take a look. If you have a string here AAA, right? So let's just write down A here and A here and A here, right? So this is your original string, right? How can you make this valid? So I have to put BC here, then it will become ABC, and I have to put BC here, so this part will become ABC, right? And I have to put BC here so that this part is also ABC, right? So that this considered as a valid string. How many characters we have inserted? 6 characters, right? So this is what we want to find out. The output is 6, right? So so you are getting idea what they are saying, right, with these examples. So if your string is given as a ABC, you don't need any insertions there, right? So 0 insertions are required, so output is 0. So this is what the problem says, correct? So this is the important thing. A string is called valid if it can be formed by concatenating the string ABC several times. So let's take a look at this another example I created for you. So ACB is your original string, right? So let's write down ACB here. So this is the original string. Now you want to make it a valid string so that it should follow the ABC pattern basically, right? So how can you make this a valid string? So first thing is you can insert A here and you can insert C here, right? So this part is valid now. Yes, you can insert B here, correct? So this part becomes valid. Agreed? So how many characters we inserted? 1, 2 and 3 characters we inserted, correct? So output is 3. This is the minimum number of characters that you will need to make a valid string in this case, right? 3 characters, correct? So this is what the problem says. So now I hope that you are clear with the problem statement, what they are saying. So how can we solve this problem? So we can use a very important data structure called as stack, right? So we will use a stack data structure here. So we will create a stack. So stack is a very important last in first out data structure, right? This is also called as LIFO, right, in computer science, right? Last in first out. So what we will do in this stack, we are going to add all these characters in this string. We'll go from left to right. We will put these characters into stack. So how your stack will look like? Your stack will look like this basically. So right now you put A here, then you put C here, and then you put B here, right? So this is your stack. So far so good, right? Okay. Now what we will do after that is uh, we'll start processing each these characters in a loop until the stack becomes empty, right? In always in that iteration we will check three things here. We will check three things. What three things we will check here? We will check if the current character on the top of the stack is character C, or after that we will check if the current character on the top is B, and after that we will check if the current top character is A. Why we are checking like this? Because the valid string is a sequence of ABC, correct? ABC. And since we put these characters into the stack, this is actually having a reverse order. So first you will get the last character when you get from the stack. So this point is clear to you, right? When you retrieve from the stack, you will get the last character first, because this is the character you pushed last here, correct? So you will first get B here, right? So you first wanted to check if this character that you are processing, if it is a C, then you will check if it is a B, then you will check if it is a, because A, B, C are the valid strings, right? Correct? Okay. So now you will, let's go through this example so it will be more clear, right? So you are looking at this current character, right? Okay, your current character is B. Is this C? You will create one counter also. So I will write a counter here. So count is 0 in the beginning, right? So is this C? So you are checking three conditions you will check, right? This is the condition 1, this is condition 2, this is condition 3. Always you will check these three conditions. So if this is a C, no, this is not a C character, right? So you will increment the count. So your count becomes 1, right? Okay, then this condition you check. Now you will check if this is a B. Yes, this is a B, right? This is a B. So you will remove it from the stack, right? So this character is removed from the stack. Now your pointer is here, right? Your top pointer is here, right? Because you removed B. Then you will check if this character is A. This character is A. No, this is not A, right? This is C. So if it is not A, then you will increment the count. So your count becomes 2. Correct? So what did we do here basically? Right? What did we do here? So when you are processing B, you want to make this a valid string, right? You have to insert C here and you have to insert A here so that it becomes ABC. So it is not possible with this current string, right? You have ACB. So it means that before B you have to add A, after B you have to add C so that it becomes a valid ABC string. So you, how many characters you added? You added 2 characters. That's what the count is telling you here. So you got it, right? You added 2 characters so that it becomes valid. What characters you added? You added A here, and after B you added C. So this part became valid, correct? Okay. So this is clear to you. Now we are in a loop. So this loop is over. So you will again go into the loop again one more time, right? Okay, one more time. You will again check. So this loop means this character you process CBA. All characters you process once, right? Now you are in a loop. So you will again start processing from C. So again you will go here, right? So is this character C? Yes, this character is C, correct? It means that you will remove this character, this pointer from stack. You will remove C. Your current character pointer of the stack will go here to A, right? Okay. Then you will go to the B. Is this character B? No, this is A, this is not B. So you will increment the count. So it count will become 3, correct? Now you go to the next condition. Your next condition is if this character is A. Yes, this character is A. It means that you will remove it from the stack, right? And your stack becomes empty, right? So it means that your count will tell you now how many total minimum characters you have to insert so that this string becomes valid, right? So what we did essentially is, if you write down this original string, what we have done here is you have added C here, you have added A here. That's what we have simulated, right? By using this counter logic, right? When you are processing this other remaining string, here you have to add b here, so your count was increased again by 1 here, right? Here your count became increased by 1, right? So this is again, this became valid, right? So this is what exactly we have done, right? And this one will tell us the minimum additions to make the valid string. So I hope you understood this logic clearly, and you also understood why this works, right? Because we always get these characters from the end, because this is a stack. Whatever you push last will come out first. This is why it is a LIFO character, LIFO data structure, last in first out, right? So you first you will get B, after that you will get C, after that you will get A from the stack, correct? So this is the logic to solve this problem, right? So you understood it clearly with this example, I hope. And how this count logic works. So every loop we will check these three conditions in sequence. This sequence is very important. First C, then B, and then A. Why? Because A, B, C are actually our valid strings, right? That's why we are checking C, B, A, because we are processing from stack, where you will get the order in a reverse sequence, correct? Because stack is a LIFO data structure. Okay, so this is the way you can solve this problem. So let's go ahead and implement the same in Java now. So this is our Java solution. Add minimum is the method where implementing a word is given to us, which is a string. This method returns int, which is minimum number of insertions. We'll create a stack. Now stack is going to hold characters, right? So we'll go through the given word string from left to right here. I is equal to 0, I is less than word dot length I plus plus. You will read the character at the ith position. You will push it into the stack. This is exactly what we have done here. So first you read A, you pushed A, then C, then pushed C, then B, then pushed B, right? After that you will create one counter, which is 0. While stack is not empty, you will start processing this, right? If stack is not empty and stack dot pick is equal to C, so if it is first, always you check C, right? First always you check C, then B, then A, right? That is the sequence is very important. So stack dot pick is equal to C. If it is yes, then it means that your C and has matched actually, right, with the stack top. If it is matching, then you are going to remove it from stack, right? Stack dot pop will remove it from stack if it is matching, right? If it is not matching, then you are incrementing a counter by 1. It means that you have to insert a character C there basically. Okay, I'll repeat this sentence for you. It means that you have to insert character C there when you are incrementing this count, right? Okay, then you will check if this stack top is B, right? If stack top is equal to B, then you are going to pop it, because you are checking the sequence CBA, because we are processing from stack, right? You will remove it from stack here if it is B. If it is not B, then you will increment the counter. You are simulating that you are inserting a character B there. Okay, then you will check for a character A. If the stack top is character A, then you will pop it, right? You will remove it from stack if it is A. If it is not A, you have to add that character A there basically, right? Then you will increment the count, correct? So you will keep looping in this while loop and keep simulating the validity of string, and you are simulating that what characters needs to be inserted so that the string becomes valid, right? At the end you are going to return the count, will tell you the minimum number of insertions we are required to add into the given string so that it becomes a valid string. So let's go ahead, execute this code, make sure it gets gives us correct answers. For the first example we are expecting 2 and we are getting 2, which is a correct answer. For the second one we are expecting 6 and we are getting 6, correct answer. For the third one we are expecting 0 and we are getting 0, correct answer. Submit this code to the Leetcode, make sure it gets accepted. And as you can see, the code is successfully accepted by the Leetcode. It is 100% faster on the performance side and 100% on the memory usage, which is a very good stack based solution to solve this important coding problem on Leetcode 2645, minimum additions to make valid string. Another very recent medium complexity string based question. So I hope you understood this logic and you understood how we have used stack to solve this coding problem, and you also understood this Java code and you like this solution as well. To help you, like, we are going to add this Java code for you in my GitHub repository, so you can check it out later. There are lots of other algorithmic and programming solutions already implemented are available there for you in the GitHub repository, so don't forget to check them out. They are important ones. They are recently asked questions by big companies in their interviews for mid-level, junior level positions, so do check out those solutions there. If you like the programming solutions in the GitHub repository, consider giving it a star on the GitHub repository. That would be great. If you are new to this channel, there is a very important coding interview related playlist to help your interview rounds. It is called as Leetcode and Leetcode solutions. More than 200 most frequently asked very important coding interview problems are compiled for you under one playlist. Those problems are asked by many big companies, including Google, Facebook, Amazon, Apple, Microsoft, Yahoo, Uber, Lyft, LinkedIn, Netflix, and many others. Many times in their past interviews. They are very important problems. Make sure you go through all of them, understand them thoroughly. If you go through all those videos and problems, you are going to learn a lot about data structures, algorithms, problem solving, logic building, programming, and coding. It will also help you learn lots of new techniques and ways of problem solving. So check out the important problems. The name of the playlist is Leetcode and Leetcode solutions. Now, if you are a fresher junior level developer and you want to practice more coding problems for your interviews, to help you with your practicing, we have created 3 other playlists for you here. The names of those playlists are Code Forces, Code Chef, at Coder. If you go to the playlist of this channel, you will find those playlists listed out there. Lots of interesting, important, and exciting problems are waiting for you there. If you like today's Java solution, where we have used this concept of stack to solve this important coding problem on Leetcode 2645 minimum additions to make valid string, then please give it a thumbs up to the video, give it a like to the video, subscribe to this channel. Subscriptions are very important because that's how the videos can reach to other people, so others will also be able to watch and learn from these videos. So do subscribe to this channel, share this content with all your friends, your colleagues, so they will also learn problem solving and programming. Click on the bell notification icon button right away, so you will always get immediate notifications for all our exciting and upcoming interesting videos from this channel. If you are a fresher junior level developer and you want to learn how to solve different programming coding questions, you want to learn how to use different algorithms and data structures in those problem solvings and how to write and implement their Java code. To help you with all that, we have created lots of solve coding problems videos on this channel that you can use to prepare well for your coding rounds of interviews. You can also use them to learn more data structures and algorithms. Those important varieties covered here includes dynamic programming, graphs, matrices, binary search trees, breadth first search, depth first search, cadence algorithm, binary search algorithm, Kruskal's algorithm, Dijkstra algorithm, sliding window algorithm. There are lots of other important data structures related coding interview problems available for you on this channel. That includes stacks, queues, priority queues, hash table, hash map, tree set, hash set, linked hash map, linked hash set, arrays, linked list. All are important problems. Those are selective problems. Those are the problems asked by big companies in the different positions like freshers, junior level and mid level positions many times. So those are important problems. Make sure you go through them, understand them well. They will give you good preparation for your interview rounds, will help you learn lots of computer science and programming related concepts. If you are planning to take Java interview rounds, there are lots of Java related videos we have created to help others on this channel. For example, frequently asked Java telephonic interview questions and how to answer them, Java design patterns, Java architecture, SQL programming questions to the freshers, where they will give you database tables. They will ask you to write SQL queries, where you may have to use different database concepts like inner join, outer join, left outer join, right outer join, aggregate operations, group band, having clauses, different where clause conditions. Everything is explained in those videos along with MySQL queries. There are videos that discusses important concepts of MySQL windowing and ranking functions as well available on this channel for you. So make sure you check out those videos. There are videos that discusses recently asked questions about Unix, like Unix commands, Unix utilities, shell scripting questions. All are here on this channel for you to help you in your interview preparation and learning different computer science concepts. If you like the videos on this channel, if they're helping your learning process, your programming concepts, you are learning more programming and problem solvings here, then do leave your messages, feedback and comments below these videos. Your feedback and comments are very important for us. They increase our motivation to create more quality content videos on this channel to help others, so others can also get helped in their interviews. They can also get to learn lots of new concepts and programming here. Keep learning, keep coding, keep solving more varieties of coding problems, and most importantly, keep your learning process and practicing going on continuously. And thanks for watching these videos.